All right, this thing on? Okay, let's get started here. So, hold on, I have this stream going. One moment here. So sorry, this makes for bad streaming. All right, there we go. This is where I actually want to be. Okay, so now that that's out of the way, so let's first start off. Let's get this running, but first let's create a branch, and we'll call this one 0x02 for the third one, and we're just going to base that off our first branch. So let's get this started. Let's actually do, just in case there was some updates, we'll do a yarn setup, and this is just going to delete things and delete all dependencies and bring them back in. So if you want to look at the code, there should be a link somewhere. Let me see if it's in the description itself. It is not. So let me copy that out real quick. Copy that to do plus, and that is going to be here. So if you want to follow along. Hey, welcome, Yuri. Yuri says, yeah, finally able to watch one of your live codings. I hope it's to your liking. But if you want to follow along, there is what we're doing, or what we're working on. So we're basing it off of, oh no, did I not update? Goodness gracious. Well, there should be another branch on here. I need to get that README updated. So this is the branch that we're actually basing it off of. So sorry about that. I'll get that updated this evening when I get off. So that should get you to the code that we're actually implementing here. So we have this. We created our new branch. So let's give this a yarn start, and we'll see where we left off. So what we're basically doing is just going through and redoing this to-do app. We're going to implement the initial thing and then get it going with some additional features. We're going to add descriptions, different ways to add tagging and add priority to the different tasks, also being able to provide task lists, to the to-dos. Also provide task lists and descriptions and different metadata that can be associated with it. But first we need to get this first one built out. So where we are right now, let's just make sure we're cooking, and we are. We'll just reuse this window. LinkedIn, that's silly. So let's go localhost, and we will go here. So what we have here is just the ability to add and mark these. But when we left off last time, we had a kind of bug here. So let's see what the bug is. If I do laundry again, and put that in there, watch what happens. When I click this, we're going off of the title and just doing negation on it. So went on the assumption that no one's going to put two tasks in with the same name. So what we're going to do is get rid of that assumption, and how they handle that in here is they use this nextId ID. So one of the things you'll notice about this, and one of the things that gets me, is inside of this action file, they actually have some internal state. And this is state that we have no control of, so it makes it hard to test, makes it hard to do things that we would want to do with this state, like if we want to test it. Also, it would be nice to have a main ID pool. So like when we start adding tags or things like that, we have a pool of IDs that we know are going to be unique within our data model that we're working with. So what we're going to do is we're going to move this into our state itself. So into the actual Redux state. And it'll make it easier to reuse and to deal with. So to do that, let's jump in. I believe we're putting this all together here. Yep. So this is our initial state. What we want to do is add something called nextId, and that's going to be an integer that's going to hold whatever the next ID is. So we'll have these being ID. We'll just call this 1, and let's do a little bit of this, and we'll copy that and just paste that in right there, and we can increase those. So what we want to do is then have the next ID be 4. So every time that we pull from this ID, we want to be able to increment it. But we want to increment it separately. So because of how we built our little helpers of how we combine our reducers and stuff in the form that we have it here, we aren't able to have actions that expand. So this is where using the state monad is going to come in handy for us. But as we're going to be adding a couple new actions to this, or working with actions and wanting to peek at our state, you may notice that we don't have our, oh, where is it? We don't have our Redux panel or our Redux dev tools opening up. So, oh, what happened here? So we have something silly going on. ID. Why is that coming up like that? That's interesting. Let's give this another refresh here. So the only thing that's coming in is that. All right, so we'll figure out what's going on there. Let's put this back to the way that it was just for now. And we'll deal with that after we get the debugging tools set up, because that might be able to help us see what's going on with that. So let's now notice here in this index file, we have a bunch of bits set up. This is where we're taking our data, merging it with our reducers, things like that. Since we're going to add a enhancer to this, it kind of makes sense to move it into its own file and get it out of here. And then most of the times you'll see a lot of people will create a configure store file, and this is used to basically get the store working and provide us with the instance that we will provide back. So let's just do the same sort of thing. We'll create configure store, and let's just move all of the things that we really care about. Basically everything to do with this store, we're just going to move into this file, and we will paste that in. Of course, we're going to be missing all kinds of stuff. So let's expand this. Yeah, we're good there. What are some of the things that we need? Now that that's moved over, this will help us. And we'll just move that over, and we need create store to move over. And we need a way to actually export this store from here. So here we'll just do export const and store, and we'll move that down so it's legible. And if you have any questions or anything, or something strikes your fancy or whatever, feel free to just leave a comment. I keep checking over there, and if I see something, I will take the time to answer any questions you may have regarding this. So don't be shy. It's fine. All right, so now that we have the store in here, we need to get this working again. So let's do import, and that's coming from library. So we'll do import store. And we'll do that from, and this will come from data and configure store. And I'm thinking that's a bad name for this, because maybe we just want to call this store, because we're returning the store here. We're not actually having a file or something. We're just going to build this right in place. So this export const store looks a bit strange to me. Well, yeah, you're right. Good call, because I would have had to have done it like this, right? And that's not what I want to do. So that's probably why it looks strange, is this is not what we want to do. So here we'll do, bring that back. And I mean, we could just do it like this. Actually, we can do, make it even more terse. Export default. Good call. Thanks, Yuri. And we'll export default create store, and then that's just going to run our function and get us back our store. So let's see if my linter allows this. It does not. Okay. That would have been really cool, but because we are going to kind of extend over here. So let's see. The other thing we wanted to do is rename this file. So let's just save this down, and let's rename this to store, because this is actually what it is exporting, right? So this is doing the store. We'll give this a little refresh here. And that's interesting. That's really interesting. My little thing is mixed up there. All right, and so this we will do a delete F and insert to store. I wonder if I messed up the order of stuff. Okay, so now we have that, and hopefully, cannot resolve data reducers. Yeah, see, I did mess something up. How did I mess that up? Why can't that find data reducers? Oh, that's in this file. This is actually going to be that. References are hard. Okay, so now we're back. We have everything doing what we want it to do. Everything is set up, and we can add stuff. Okay. And we will do cake sniffer, so that way we remember to sniff cakes, and there we go. Okay. So we'll give that what I like to call a little refresh. Okay, so now that we have everything out of there and we're just bringing in the store, we could even do things to where we have the provider and kind of do a higher order component or something like that here, but I'm not going to opt to do that. So what we need to do now is get our enhancer in there. So on here we have on our window, or we can do global. But we'll just do window, and we'll do window, and it's going to be this compose here. So what we're going to do is just copy this, and actually let's take the whole thing. And I'm all right with doing, this is kind of a something you would normally put in an IO and then run it when we're ready to go, because we're pulling from some shared mutable state that may or may not exist. But we're going to just capture that. This is JavaScript. So we're just going to capture that here with a little function we call compose enhancers. And with that, we're just going to make that equal to, and this is going to be the composition function that we're going to use to put together all of our enhancers. Right now, we don't have any enhancers, but I'll show you what we're going to do to deal with that. So here we just paste that in, and I think we're pretty much done with this file, so we'll just close that. That way we have some real estate here. Oh, goodness gracious. And what we're going to do is OR this with compose itself. And we're just going to, we could bring in the compose from crocks, but since we already have this in here, we're going to bring the compose in from Redux. And this is going to now give us a composition file that we could use for... and we will do, like we could put our apply middleware, things like that in there, and it will build the functions for us. But since we don't have anything right now, we'll just use a simple identity function, and just to give it a name, we're going to import identity, just so we know what it is. We could look and see X to X or whatever, but this will at least give us a name of what it is. And we'll import this from crocks combinators. Oh, goodness gracious. Combinators. And this is going to be identity. So now all we really need to do, hopefully, if this all works, is do compose enhancers. And let's see what this does for us. Okay. And now we can do that. And we'll compose enhancers with, for now, we'll just put in identity. All right. Now, we could do something like this and say enhancers, you know, and then maybe put this in and then do identity. And then we could do our apply middleware or whatever. But really no reason to do all that right now because we don't have any and identity works for us. So we could do that, but there's no reason to do it really. So now let's see how broken we are. We're not. And if we notice, we have our state actually coming through and we can send actions just like that. So we'll just go to Redux here. And if we look at our actions, there's our toggle to do action. And we'll notice that it did its change. So this is all working as expected. Completed is true on that. We can toggle that back. And let's take it off of that. And now we can see that it's changing. So if that makes sense. All right, so now with just that simple statement, we have our enhancer set up. And we have it in a way, again, later on we can compose together where we'll have an enhancer for an async and maybe a promise enhancer or middleware. So we're going to use the apply middleware, which we'll add to this. But we don't need to add all that right now since we don't have the need for that. So this is just a compose enhancers is basically just the compose function. We don't really need to define that. All right, so now we have our store all ready to go. The next thing we want to do is, oh, actually, let's jump back in there. I'm still curious about that. I wish that was working a little better. I wonder if that... So let's see, we'll do nextId here, and we'll put 4 in. Let's see if that fixes things. So we look at our state, bring that here, and our nextId is 4. And now let's see what happens. Let's see what I got wrong. And we'll do 1 like that. Oh, you know what? We could do that like this. Okay, paste that in, and then this, and that. Okay, so I bet it's something to do. We might get an error in here. All right, so I'm wondering why we're getting only that one to do show up here. So that's really, really interesting. So let's take a look as to what could be causing that. Let's jump into to do. So this takes the to do, and what we're going to do is bring an ID, and this will be a number. Oh, yep, number. Okay. And, yeah. Okay, so what could be causing this? All right, maybe it is something to do with our to-do list. Map to-dos, we have our map dispatch. You know, like that should be okay. All right, so maybe it's something to do with this. But that to-do is coming in as is. So this is really interesting. All right, so here we have ID, we have title, we have that. Here we have ID, we have... Oh, that's the problem right there. Goodness gracious, I made the same mistake. All right, so let's get into the data. See, I'm so glad we got that working because it tells me what the problem is. So if we jump into store, notice that all we have are idles. So what we need to do is put in titles. So there we go. Sorry about that. How embarrassing, right? All right, so now we have our stuff back. We have our toggle. We got our ID in there. Now let's add our state. Now let's add, we got nextId. So we have everything in there. Now, let's talk about some fun stuff. Normally what we would do is, in doing this, we would have a reducer or something that would take care of that nextId namespace. And what we would do is, using their combined reducers, we would put in different actions. So we would have this add to do that would go ahead and increment the nextId. But the problem is we can't communicate between these spaces very easily. But in using the state monad or the state ADT, I hate to say state monad, but the state ADT, we are able to actually jump between the different namespaces. So how we do that is everything in these ADTs, or at least with this state, is, let's see if we have some type signatures here. So notice how everything here, a majority of these, returns something like an app of a state of AppState in A, right? So what that's doing is it's not running any of this stuff. It's not running any of these functions. It's not doing anything like that. What it's actually doing is going through and loading this function to be ran on the state whenever we provide it. So all of these transitions that we're defining, we're just saying, hey, move the state in this way or interact with the state in this way. And then eventually when we chain these together, like we see down here, and these are all pretty easy, not much going on. This will get a little more fun while we get the ID in there. All we do is chain together the different ways that we interact with these functions or with the state itself. So to be able to get to that, we can't really, or to get to this nextId and to work on that, it really doesn't make sense since it's in a whole different namespace to put it inside of this model file. So what we'll do is we'll make a nextId model file, and this will handle all the state transitions that work on just the nextId, right? If that makes sense. I'm going to assume yes. All right, so we're going to need a couple things out of here. We're definitely going to need the state, and I'm pretty sure we're going to need to get and modify things. So what we need to do now is we'll create a function that, goodness gracious, what should we call it? We will export default, and let's do, just for now, we'll do const, and no, we don't want to export default. We want to export, and we will const because we want to have all of the functions available here that will provide the state transitions that we can use. So the other thing is, notice whenever we have these that are exported out, every one of them has a straight state return, and it moves from some sort of A. In this case, it's always an object to the state. This is what we call a Kleisli arrow. So the cool thing with these is we can compose these together. So the same thing is going to happen in all of our model files. Every single one of them are going to have this signature to it, where it takes some A and then gives you back a state of some kind. So what we want for this, and we'll just call this, what's a good name for it? We'll call it GenID for generate ID. Because it doesn't need to know, the consumers of this doesn't need to know how that's generated, because we don't care about the state that it's managing inside of our state. The only thing we care about from this is, and you know what, maybe nextID is a bad name. We'll deal with names in a little bit. Let's just build this out real quick, and then we'll deal with names, because nextID kind of sounds like a function. So I don't know. We'll rename it after we get something in here. So what we want to do is we don't have anything really that we need to pass in. This is going to be something that goes from unit or undefined. It's basically just something we'll call. And we're then going to return a state of AppState. But what we're also going to return is some sort of number. So we're basically returning a state of AppState of number. A bit late to join, but had a quick question. What's the difference between the state monad and the reader monad, and when's a good idea to use one or the other? So the difference between, to answer your question, the state monad is used when you need to, or the state ADT, we should call it. It's a monad whenever you use it as a monad, but otherwise it's an ADT that can be all kinds of things. But anyway, to use the state ADT, one of the things, or the main driving factor for that is when you have shared mutable state between a family of functions. So maybe I have a bunch of functions that work on some shared mutable state. Like for instance, in this case, the AppState inside of Redux. This will allow us to organize and kind of provide a clear path of the different state transitions, grouped by functionality or however we really need to group it. But it'll allow us to, I don't know, you would use it whenever you want to modify that mutable state. Now, the time you would use a reader is whenever you just have a shared environment between them. Or if you start getting into adjunctions and stuff, nope, we're not going to get into that. There are other cool things you can do with Reader, but for your most part, most of your apps like this and things like that, Reader's basically just going to be when you have a shared environment. So the common case for that is like, I have a database connection. And what it does is it allows you to have all these functions that might work with that database connection. and I can put together all these different transition or all these different ways of using that environment or that database connection, and not have to worry about that database connection at the time I'm defining it. And then at the edge of my program, whenever I have a database connection, I can run any of those transitions, or not really transitions, but those functions just by passing in a connection to it. So it's basically when you want to work on shared mutable state to where you want to mutate the state between a family of functions, then you would reach for state. When you just have a shared environment, then you reach for reader. There's, I don't know, you could do once that, and that's more of like the practical mechanical way of using them. You could use it to represent and like move from an ADT or some sort of functor into just a normal function and then back and forth. But I don't know. That's not really a top. We probably won't be using any of those techniques in this. But who knows? Maybe later on we'll play with them a little bit. Yeah, that's kind of out of scope for this. But for the most part, it's when you had a shared environment, you would want to do that. So what we want to do, and notice I could just return a state here. That's really all I really need to do is just return a state. But we want to make sure that we have it as a function. And this is kind of weird because we take nothing. So this would always have to be at the head. We couldn't use this in like a Kleisli composition. But I don't know, it would be kind of weird to take something because we can't really query it on. We have to have a number from that. But I mean, you could pass something in here. It's just the result of one function. It's just not going to do anything with it and always give you a number. But I hope that helps. Okay, so here we have our gen ID. Again, we are going to have some sort of transaction that returns some sort of state. Okay. Right now, we're just going to put it like that. It's not doing anything for us, but it lets us kind of know how we can flesh this out. So the first thing we need to do, because if we look at our state, this is going to be the state that this AppState represents over here. So we have this nextId. So what we need to do is pull that nextId off of this state, kind of like what we did with this. See how we have this map to-dos, and then we have this prop array, bring in to-dos, things like that. So one of the things we could do if we want to, copy doing that, we could use another maybe. So if we look at this helper here, just so you can see what that's doing, kind of a refresher from last time. This is basically just going to make sure that the key exists. In this case, it's to-dos. Then it's going to check to see if it's an array by chaining over that. And then it's going to option that out. So it's either going to give us the array that was on that key, or it's going to give us an empty array. So we just made a little helper because we'll probably be using this here and there. We're not doing a lot in this file. We're really just going to read something and we're going to give something back. So instead of like working in a maybe and doing things like that, this might be a perfect opportunity to use prop or, because that'll give us kind of what we want or what we would need. See, numbers are a little trickier than arrays because an array, I can always get an empty array to work on it. Sounds like a selector function. Define selector function. Oh, yes, a selector function for, yeah, it's like a selector function. Yes. Yep. And it's a selector function that you could like assign to a type or something like that. And you know what? The more I talk about this, we probably always want to make sure that's number. We want to make sure that's number. Okay, you know what? I was planning on doing that, but let's go ahead and always make sure that we have a number. And start from 0. All right. So one of the ways we could do that, see, this is where I start going off script and then everything goes to heck. I had this whole thing planned out. Okay, you know what? We'll go back and redo that because that's going to force us to have to do another refactor to clean up that other code. But you know what? Maybe that looks good. Maybe it's fine. to see what refactors like that look like. So maybe that will be very, very helpful. All right, so for now, let's go ahead and close that out. And just for now, we'll close this out. Nothing's referencing it. We'll jump back into that so we have some real estate. Okay, so what we really want to do is have some sort of check to make sure that everything's fine. So what we can do is let's create just a simple, and we don't even need to put this out into the universe with an export, so we'll probably move this up. We may want to, but we're just going to use a helper function for defining these things to check a different type with something else. And we don't even need to do a type. We can just say, but then we need to provide the option. Okay, that's why. That's where it gets complicated, because the option needs to be provided as well. And normally, like I said, for an array and things like that, it's easy because it's always empty. But a number, sometimes a 1 makes more sense than a 0. So it's really hard to make that. All right. Let's just jump back into here. And sorry, I decided to close that out for some reason. And this is what I do. I just waffle and waffle and waffle. I should realize that I probably already thought about that. So let's go back into models. And here, just to keep things rolling, let's just do an import prop or. And we'll bring that in from crocks. And that will be helpers. And this will be helpers. And this will be prop or. So now we bring in the prop or. And then from there, what do we need? What do we need? So now what we want to do is basically pull that off. So we want to use a get, and let's do this, and we'll call this get next ID. Okay, and then get next ID is basically just going to be a get saying go ahead and give me all of the state. And then we're going to do a prop or. And the prop or takes the 0 first, or it's empty, or it's a null value in the case that the prop doesn't exist. Otherwise, we're going to take next ID. Okay, and that's going to, whenever we do this, it's basically just going to get us back this next ID. All right, so now that we have this next ID, we need a way to, let's just say we have the number available to us now. So in this case, it's going to be 4, right? So we'll have our 4, and that's going to be in the resultant part. So that's going to be over here in this part here. And because this is the next ID, this is basically what we're going to want to send on to us. So right now, at this point, we have a state of AppState of number with this get. But we need to do a state transition to increment the actual next ID. So what we can do, we're going to need to use a chain here. And the reason why we need to use a chain is we're returning this modify, right? And there's probably a better way. I'll probably think of a better way to get this done. But for now, let's just, we'll call this ID. All right. And because ID is the ID that we just pulled off. We could call it next ID. We could call it whatever. And we're probably going to change around what this function does anyway. But if we remember, chain always needs to take a Kleisli arrow. So it needs to take something from an A to an M of B. So in this case, we need to take an A or a number to a state of number is what our target is, right? So in order for this to work, we need to return another state. And to do that, since this is doing modification on it, we'll do modify. And modify takes a function. And so what we want to do with this modify is actually commit it back up. So what would be a good way to do that? So let's create, we're going to get into this weird nesting here. So what we're going to do is chain that. And this will be ID. And then what is that? We'll call this increment ID or increment next ID. And we want this to return a state. So this is going to take the ID. And then we're going to do modify. And with this modify here, we're going to want to do an associate. And we want to update the ID. So let's bring an associate or ASOC, whatever. And this will be in helpers as well. And this is going to be, all right. So we want to associate that. And I mean, we could get all fancy and do all kinds of crazy stuff, but we basically just want to take the state. So what associate does is it's going to take a key, a key name, and then it's going to take a value, and then it's going to take an object, and then it's going to associate that key value pair. So this is going to be the key, this is going to be the value, and it's going to increase it by 1. And then once we get the state, because what modify is going to do is give us the state and then let us work on it. So now we can take the state, update the ID, and then it'll merge it back in, and then we'll have the D there. But we need to do something else, because anytime, if you've seen that egghead course or anything like that, anytime we use modify, this is going to give us back a state of state unit. So it'll be something like this, right? In our case, this will be AppState. So what we need to do is map some sort of constant. So we always return what this last ID was. Because remember, this is the next ID. So how we do that is we need to map. And this is basically going to take from the unit. We're going to, since that's what we have in the resultant is a unit, we need something that will take a unit and give back that ID, whatever that ID is. So what we'll use is a function called constant. Import constant from, and we'll say crocks. And this is a combinator, so we'll do combinators. And that's going to be constant. So this is basically the K or constant combinator. All right, so here we just bring in, how do we say, we'll just do a simple map there, and we will do constant, and this will be ID. So now this is going to give us back the thing that we desire. So this will get us back a state of AppState, and then because we are going to take the unit that is inside of modify, and we're going to map unit to this ID, that's going to give us back a number as that ID is number. So this gets us the type signature that we're looking for. This is the type signature you're looking for, which means that we are all good there. So now all we really need to do this gen ID is we don't really need that. No need to make that extra bit there, but we do need this increment next ID. And we need, since this is going to put whatever the ID is inside of the resultant, this is going to chain with increment next ID. Okay, so now we have that. Let's see if we can hook this up. Because now it's going to get a little funny, right? Because we have, if we look here, we need to take this app state of number. And we also have this app state that, how would you say, whenever we do this add, because when we add, that's when we want to actually increment the number and put the new ID in. So whenever we do all that, what we want to do is we're going to have to move this around a little bit. This map to dos is pretty good. We have that concat going on there. But I don't know about this map to dos. We might have a cleaner way of putting that together. And we could probably do that with something called create. Another thing that kind of bums me out is we need to get this default in there. And the way that this default works or is working, what would be a good way to do this? All right. So what we really want is not really for this default to do, but we want a function that's going to use this default to do, because we want to make sure we default our apps. But we want this to actually return a state of AppState to do, so we can get it in the flow and get it to compose through chain and different functions like that. Well, mostly chain. But I really like, to be honest with you, if we were to like put this in a composition and things like that, we're going to have to break all of this stuff up anyway. So let's just create another function here that we'll call apply defaults. Defaults. Okay. And this will just apply our default objects. So, or our default parameters to our object. And this is going to come in at, let's see here. So this is going to take an object and it's going to give us back our state, app state of object. And we can close this out for now. We'll come back to that once we do the refactor there. Okay, and this will be of to do. So now we're going to have a to-do in the resultant that we can, do other things with and get it in these chains. So that way we're always working inside of this state and can be very clear about how our state should transition for all of these different actions. So here we just do const apply defaults. And I mean, there's a couple ways we could do this. So we basically just want to take an object and then we want to wrap it in this state, giving back the to-do after doing that. So what we could do is take in the, let's call it record, because it's not really a to-do at this point, it's just a record. And we'll just make this easy on ourselves for now. We'll just do a state.of to lift that into there. There's other ways we could get around this. And then we'll map that with the default to-do. So now this will take any record, and then once it runs it through here, well, actually this will give back another object because it's not really a record or a to-do, because we also need to have an ID of number for it to actually be a to-do, right? So we don't have our ID yet. All we did so far was we updated this to if completed isn't provided or if title isn't provided, it would take care of that for us by having it be defaulted. Okay, so now by doing this, what we did was we lifted whatever the record is that we're going to pass in here. We've lifted that, and let's see here. Okay. So here we're going to get back our to-do, and this is going to be what we need. So let's do and actually, I bet you, let's comment this out because we want to copy it and then we'll paste it and then comment this bottom one out. Get rid of all of this and get rid of this because we don't really need to, this would be a perfect example for using compose K, right? So we'll do compose K. And what compose K does, remember I was mentioning those Kleisli arrows? It lets you do composition on Kleisli arrows as long as the M that you're returning, in our case it's a state, it's going to, as long as everything returns a state, it's going to be able to chain them together just like you would with a normal composition, like in JavaScript, how we would compose in the category of JavaScript. This lets us compose into some Kleisli category that we've defined. I'm using that term very loosely and very wrong, but okay. So we have this apply defaults. What else would we like to do? So what we want to do is now that we have this apply defaults, I guess we could really call this create. No, this wouldn't be create. So what we want to do is apply defaults to this. And then we need to create it. So we will do apply defaults. All right. And then the last thing that we need to do to create this object, or the next thing after that, is we need to generate the ID. So let's create a function called create, and we'll go through and put, kind of organize these in a little bit after we just get something in there. And we'll call this create. And what we want to do with create now, this is where it gets a little funny, right? Because we have two different branches of states going on right now. We have the state that's over here inside of our nextId. We have this state, which is to this number. But over here, we have another state that's kind of in parallel. You can think of it in parallel, which is working on the state that's handling this to-do action. So we have two different states working on different parts of the state. And what we really want to do is bring those two paths together. So this is a case for using what are known as applicative functors, right? So if you think about like AP and those functions, mechanically, you may have heard it described as a way to, if I have a function, now I can apply parameters to a function that's, over in my right side. It allows me to map, because otherwise I couldn't map to do that application. So mechanically, that's how it works. But at a higher level, you can think of it more as a way to combine different paths or different effects that are kind of branched out and happening in parallel into one. It's a way to join two separate things. Whereas when you're using, like, say, the monad portion of it, you're working on one flow that is pretty much step by step in sequence, right? That's why it's called chain. So how would you say? So instead of thinking of using applicatives in the case of when, I have a function over, you should really start thinking of it more as I have these two different effects, or these two different things that have these effects, these data types, and I want to merge them into one effect. That's when you'll reach for things like lift A2 and things like that, right? So what we want to do is take the ID from genID. So remember, genID is a function. So we need to do genID, and that's going to return our function. We need to, of course, bring genID in, and that's going to come in from, we'll do import genID, and we'll bring genID in from nextId. Again, that's a horrible name, but it talks about the namespace and things like that. So this is going to grab that genID function, or that other state, and let us run it. So now we have the ID taken care of. This is going to increment the ID. It's going to take care of all that business for us, which is pretty awesome, if I do say so myself. And then it's going to, we need to now combine it with something else. So this is where using that default comes into play, right? So now the problem with this is, how do we pass that to-do in, right? We have no way really of passing in that to-do into this create function unless we do something like this. Okay. And this to-do, okay, so we have the to-do in there. And you know what? Since we already have the to-do in there, let me think about this for 1 second. Nope, because we still need to take the to-do. But, I mean, I guess we could Kleisli this. Or get this into something. Let's see here. What would be the better way? Oh, you know what we could do? So that's going to be the to-do that comes into there. What would be the best way to handle that? So what we basically want to do is merge these two things together. So we're going to have something here in nextId. And that's going to be basically the ID there. So we could probably just use, let's see, for our function, we can use assoc, and then we want to associate that ID, basically what we were doing before. We want to, now we have a binary function, which it's going to lift into a state and then apply these to. So we have a binary function now. So now we need to give it the other one. We need to give it the apply defaults. So to do that, we could just bring in our rec like that, and then we call apply defaults. Okay, passing in our rec. All right. So now we have two separate chains going on here. We have two separate things. Now let's do concat compose lift A2. So that's going to come in here. This will be, and that's a helper. So we'll do lift A2 and bring that in. Okay, there's our lift A2. And now that we have that function, this create is now going to take, it's again a, we'll do create. And it's kind of neat because we get to do it sequentially, but kind of marry them together. This is again going to take an object that we're just calling our record because it's not really a to-do yet. And that's going to give us back our state of AppState. And object, or this will actually be the to-do, because our to-do will be ready to go then, right? So apply defaults is going to return that state that will have that in there. That's going to have create. And now the next thing we need to do is, what would be a better way? So I'm wondering if, right, we don't need that, okay? So now we need a function called add to do. We also need to bring in compose k, and we'll do that, and back, and a k. So now that's going to bring in our compose k for us. And now we want to, now that we actually have this, we want to be able to append it, right? So we want to take and append this to the, okay. Where is add? We want to be able to append this. So down here where we were doing this map to do's and things like that, we can pretty much just create this function. And since map to do's, like if we go here, notice this actually, we can close this out for now. We'll, we'll reopen it whenever we need to look at it. What is going on here? This needs to go like that. Okay, so if you see this map to do's that we have here, or not map to do's, it is map to do's, but if we look at it, we'll notice that it gives us back a state of AppState to A, right? And that does take in the to-dos, and so it's going to work on a function that goes from to-dos to A. All right, so what we want to do is pretty much take this stuff, this map to-dos here, and we'll just throw this here, GC, and we'll call this const add to do. Okay, and what this function is going to do, now that we have it all wrapped up, things like that, we don't need to do this default to do. We don't really need to do any of this. We're basically going to take the to do here, and we don't need to call the default on it anymore because this is actually a to do, and we'll replace this with that. oops, this with that. And now add to do is basically going to take a to do and add it to the collection for us, right? So this is going to take a to do, and from that to do, it's going to return back a state of AppState of whatever A is. So that's going to be a to do. It's basically going to apply something to it. Yeah. And it's actually going to be a to-dos. So we will have the finished to-do with this appended to it, and all of it should be good. So now all we need to do is do add to-do. And notice how, because we have this signature matching up, we can just compose these together like we would any other function, and it's going to make sure that it does all the application of effects. Like it's going to apply all the effects for us in all the places. So then the last thing we need to do is do a commit, Edward commit. We need to do a commit here. And to be honest with you, let's fix this too, because this is kind of hard to read. It's kind of hard to tell what's going on there. So let's actually just say to-dos. Okay, so this will bring in our to-dos because that's what it takes in. And instead of doing all of that, let's just do a modify, because I think this reads a little better. And we'll do an assoc. Oops. So let's do modify. And then we'll do another asos or assoc here. And we're going to make this our to-dos namespace. And then from there, we're going to put in the to-dos. And it's now going to take the to-dos that we modified and all that, and it's going to reassociate it to it. So basically, this is going to take whatever list we give it to it, and it's just going to overwrite that assignment. Like this is how we handle the different namespacing and stuff in the different models. So now that we have that, this should just work. And if I go hello, we'll notice whenever that came in, if we look at our state, oops, nextId. All right, see, I'm so glad we got that thing up and running, right? That's because we are associating this to ID. This needs to actually associate to nextId. Okay, that was my bad. So this will clear out for us and get all of our stuff, and we'll just go happy. And if we notice our state, we've actually updated this state. And if we look at this, this gave us the ID of 4, which is now a unique ID in the system. Right? So we were able to work without doing anything with the reducer. Everything stayed in the model. Notice we didn't jump into the reducers or anything like that. Everything just stayed in our pure model inside of these two files. And by using little tricks like our understanding of how ASOCs work, or how would you say applicatives work and things like that, we were able to take these two separate paths. We have this path over here that's managing this nextId. Then we also have this path over here that's managing the to-dos themselves. And we were able, by using this applicative, to merge the two together and actually come up with a result. Defining like how this state should transition. So, and if we look at our reducers, nothing has changed there. All of our actions are still, working as expected. Okay. So now for this next part, this is the first part to fixing our bug. And just so we know like what the bug is, we made an assumption for those of us that might be joining. We made an assumption early on that nobody would ever have a to-do that had the same name inside of a set, because that would just be ridiculous, right? So we went with the ability to key off of this by using the title itself, right? So notice when I click this do laundry, it flips these two, right? And we can make it even crazier. If for some reason they're doing just so much laundry, now it does that. So what we can do now is, now that we have a unique identifier for each one of these, and notice every time we do this, it's actually updating our state every time and giving us a unique state. So that's pretty neat. I like that. So I'm going to show you, we'll go over just a quick way of how we can fix this with the code that we already have, right? So we're using this. Oh, we can get rid of this nasty. We are done with that. So all we have is just this real simple thing that defines that. We could even set this up to be a compose K, and maybe we'll do that later, because all of these functions, they go from some A to an M of B, which in our case, this is the to-dos to a state of unit. This is our to-do to a state of to-dos, things like that, if that makes sense. So that's why we can use the compose K, and we can just put all of these together like any other function. I know I'm repeating myself a lot. It's because I'm thinking, ooh, what's the next thing we should work on? All right. So we have this, we have a lot of, we built a lot of our structure around using this title here, right? So if we look at helpers and we go down to, what is it, update record. So down here, we have a predicate just saying always do this and update by the same title. So we don't really want to do that. What we would really like to do, or what I would like to do, and we're just going to jump over here and just kind of work through this real quick, is to come up with some sort of function that's called prop satisfies, right? Satisfies. All right, so we're going to create this new function, prop satisfies. And this is going to take a string. It could take a number. It could take many things, but in this case, we're just going to prop satisfies. In this case, we're just going to say that it takes a string. Then it needs to take something to, how would you say? It needs to take a function that's a predicate function. So we're going to say predicate here. We're going to say pred, replace, and then we'll do this. And we're just going to put a pred in here. And the reason why is, as we start using these, you'll notice that the different logic functions in crocks, they either take a predicate function of like an A to a Boolean, but they also take a pred data type, which is a monoidal contravariant functor. That basically allows you to do some cool things with predicates. So with all of the logic functions or anything that takes a predicate in this library, it'll take either a pred or a predicate function. So anyway, we're going to deal with that. All right, so then what we want to do is we'll take the prop satisfies, and then we take some object, and then from that we're going to return a Boolean, if that makes sense. All right, so to do this, we're obviously going to need some sort of composition. So we're going to bring in compose, and we'll just do a compose here. And one of the ways we could do that, actually, we need to set this up. So we're going to take a key, and from that key, we will also take a predicate function that we'll just call pred, and then we're going to take a composition. And then we're going to take a composition. Let me get a quick drink here, sorry. All right, so this will be set up. This composition that we're going to build here is basically just going to take that and take the function, or take in our object, and then run it through to make sure that everything is fine, right? So how we want to do this is we can just do a, let's do a prop, and we'll do a prop to bring in the key. And what prop does is that it will check a given function, or that'll check a given object, and if that key exists on that object, it'll give you back a just, or that value of that key wrapped in a just. But if that doesn't exist, then it's going to give you a nothing back. So that's basically going to put this into a maybe. So now that we have the maybe, we want to, we'll just do a chain here. And we want to apply another test against it. So that's why we're using chain here. And when you can think of chain or monads or chainables, think of them more as a way to apply the same effect of something over it. Like if we look here, if we look here, see every time like we're calling chain and doing commit, that's because the effect of a state is to read or modify the state. So every time you see this chain, it's either reading from the shared state or it's modifying that shared state. So it's applying the effect of this data type. And for state, that means working with the AppState. What? All right. So in this case with a maybe, what that means is we want to run another disjunction and we want to check something. So since we want to check something about this property to see that it's true, it's just a matter of doing safe and passing in that pred. So now this is going to check to see if, and the other thing, I'm sorry, that safe does. What safe actually does is, safe, it's a function that will take a value and then it's going to check that value against a predicate. And if that value passes the predicate, it's going to give you that as a just or another maybe. So it's going to return a maybe as well. If it does not, however, pass the predicate, then what it's going to do is give you back a nothing. So we're basically checking for safety there. So let's also bring in chain, or the chain point free function. And now we have pretty much everything we need, but we need to get this into a Boolean. So what we're going to do is option this out to false. Because if we're in a nothing, that means that either this failed or this failed. So in both of those cases, it does not match. So now we have something that... give it a file name and then reading from that file, returning a maybe error string. Then JSON parsing this as a maybe string. If you're returning an error, then you would actually not be using a maybe type. You'd be using an either type or a result type. Because the maybe type is set up to have its left side to be a nothing or a unit. It's basically tied to undefined. But if you need to report your error and know like what the error was, like what character it had problem parsing at or things like that, then you wouldn't reach for a maybe, you would actually reach for an either. In this case, this is basically not doing if else's. This is just doing an if with some default. So if we just do if this and this, then go ahead and return it. Otherwise, return false. That's, if you were to think about it kind of in imperative terms, that's what's going on there. LMNOP, so this will be option. All right, so now that has the option. So now we have this really cool function here, and let's do const, we'll just call this pred is equal to, let's see here. This pred is, we'll call it the, or we'll call it a test, right? So our test here, we want to check to see if the key, so we'll do prop satisfies. Let's just give this a little testaroonie here, see what it does. We will check the prop ID, and let's check to see if X, or that ID, is greater than, X is greater than 10, okay? So then what we'll do is we'll call test, and we'll call test with a little bit of data, and we'll give it an ID of 3. And we notice that comes back false, but if we make it 13, it comes back true. So now we have a simple prop satisfied built around the maybe type. Now you might be, or prop satisfies. Now you might be saying to yourself, well, wait a minute. Why can't we just do this pretty simply? Like, why deal with this maybe, or, you know, things like that? Well, so the case for that, what we would kind of want to do is, it would seem silly to have to specify, like as we're building out these queries and doing things along those lines, it might be a little silly to have to, like, say we wanted to check to see like if it's equals, right? So we could say equals 10. What we kind of want to do is create more of a query language. Since we have this update function, where's equals? Equals. Since we have this update function, I think what we would really want to do, I mean really, is have another function called where, right? To where, we'll say that where is a function that takes some object, so we'll call that object a query, okay? And we want to take that query and we want to kind of break it down. So this can actually be a compose. And so say we're using this, right? What we'd really want to do is do something like so if we were to use this where or whatever, we want to be able to do something like ID and then say 5. And we want that to be equals. But maybe we want to do something like where ID equals 5 or age equals 25. Age equals 25. And name. No, let's not do name. Let's just do ID is greater than 5, right? Okay, so maybe we want to write a query like this and being able to do that. So it would be nice to have any time that we put something that is not a pred or predicate into play, we want to be able to, how would you say, make it equals. So, or like have this implicitly be equals. It just makes for easier to read code and it looks more like a query statement, right? So what where is it's going to take some sort of query. We'll just call this query. Okay. Well, in an object. And then it's going to take that, and then it's going to take another object. Yep. It's going to take another object to compare that to. And then what we're going to do is return a Boolean. So if this matches, we're basically making a Boolean function. And if any of these properties match, then or match some sort of criteria, it will work in that way. So what we can do, now that we have the prop satisfies, we have this key and we have this pred there. There's a function that we have available to us called, and let's get a little breathing room here. So we'll put that, and we'll put that, and we'll do the same thing there. And what's the other thing we want to do? Let's get rid of test. All right, so the other thing we want to do, we'll get rid of equals as well. Okay. All right. So the next thing that we want to do is take an object and split it into pairs. And it just so happens we have this function, QRST, called toPairs. And we'll do toPairs. And what that's going to do is take an object and give us back a list of pairs that we can work with, right? So the first thing we want to do is toPairs. So now this gives us a list of pairs from that first object that we have. Okay, so then the next thing we want to do is we need to have a predicate. So remember I was saying that we have that all the functions here take a pred or a predicate. So we want to bring in this pred data type. And it just so happens, like I was saying, this pred data type is a monoid. So what we can do is take this list of pairs and fold it. Some predicate over multiple keys. So yeah, that's correct, Yuri. So where is going to be a predicate function over multiple keys, and you can just build that out like you would, say, a SQL query if you were to do this and this and this and that. And we're going to use pred to build that out, if that makes sense. All right, so now what we want to do is we want to do an mconcat, and we're going to get back a set of pairs. And let's do an mconcat map. So now we have a set of pairs. And what we want to do is merge that pair and apply it to a function that is going to, well, be applied to this function, which will give us our Boolean back, right? So, righty. And if you'll notice how this takes two, it actually takes two things. So we need a function in this pred because preds need to be constructed with a function that goes from some A to a Boolean, right? So we want to use merge, and what merge does is it takes a pair and applies both of the left and the right to a given function, a merging function. So we're just going to move from this pair into a function that is a predicate function. And then whenever we do this mconcat map, it's going to take that and, well, you'll see what it does. So we're just going to merge these with prop satisfies. Okay? And the other thing we need to do is specify what our monoid that we want to concat them on. So if we look here, we'll do mconcat map. And mconcat map, we also need merge, which will come after here. And that will be merge there. Okay. So now we have that, we have merge, we have all of that. Let's see how it works with the equals. And this is going to give back a pred that's ready to be run with this, right? So now if we log this out, we'll just do a where. Let's see, we'll do a where ID, and we'll bring equals back into the mix because we don't have that part. We'll just do the x is greater than 5. Okay, so now we have that where, and let's say name is equal to, so we will use equals. That name is equals to Joey or something. All right, so let's bring equals back in, and we're going to take it pretty much right out. Or actually, no, we won't. It is going to be part of the finished solution because we're going to need to map to it. So that would go here. Oops. Come on. Sorry about that. D to M, and this will be equals. All right. So now what this should get us back is a pred with a function. So now we have a pred that could be run with anything, right? So here, let's just do const test is equal to, and we will go to the end here. We will v to the end and take that out, paste that in here, and we can do some of this just to make it a little easier to read. So this is the predicate that we're going with. And now we should be able to combine each of these. Like this seems like something that we would want to do this with. So now with test, we can't just run this. We actually have to call run with. And let's just put in something that says ID is 34 or 32 and name is Billy. All right. So now when we run this, it's false. But if we change this to Joey, we get a true. So now we can use this to build out any type of query just by relying on the fact that pred is a monoidal functor, right? Well, contravariant functor. We're not really using the contravariant part. We're really only using the monoid part right now by using this mconcat map. So again, just to kind of recap what we're doing, because we're going to change a little something about this. And how we're going to do that is we're going to create another function here. And we're going to say pred, what's a good way to say it? Yeah, pred or equals. Okay. And what we're going to do with this is do unless. And here we can do we'll just do a little test here. So we're going to do another little bit. We're going to do unless, and then the thing that we're going to test for is if it is a function or is same type of pred. So now we have all of the neat stuff. This will be an or. This will be down here unless. And we need is function. I goes here. So let's, we're starting to grow. So we'll do is function and put this down here. Bring that to there. Do some of this. We could probably get another. Now let's move this down. And let's move it down here. And this will be is same type. Is same type. All right. So now that's going to be is same type. All of that's going to be pretty good. Is same type, is function is same type. So now what we really want to do, or what this is going to do for us, is it's going to check to see that if the thing we're giving it is either a function or is the same type, unless that's true, or when this is false, when this statement is false, we then just want to pass the equals function. And that's going to take, so if it's not a function, if it's not this, what it's really going to do is give us a brand new pred and take whatever that value is and partially apply that to equals, right? So now all we need to do here for this safe is pred or equals that pred. And now, notice here we still get the true because we have that function. But just by doing that simple little bit in there, we can now not need to say equals. So now we can just say equals Joey, right? And it works not only for multiple things, it also works for, you know, something like this. So I could just do 32. And that's true. So this will get us kind of a way to create some sort of query, right? And it helps us define a query type language, or a way to query a record and build Booleans out of a basic query. So now that we have all of this stuff, let's move it into our actual helpers file. All right, and we'll go through and organize this a little bit later, but it's good to keep everything up here for now so I know like what we're missing. So I know that we need to bring in, oh, don't be such a silly goose. We need to bring this in too. So let's build a signature for this. So pred or equals is going to take some sort of A. Any type of A. It could be a function. It could be a value. It doesn't matter. And it's going to give us back a predicate always. So, well, hopefully, we're going to assume that it could be a predicate. We're going to take any type A, and we're going to go from a B to Boolean. Right? All right, so this will guarantee us that we always have a Boolean there. And if it comes back otherwise... All right, so this goes here. Okay, so we need to bring in unless. And that is from logic. And we need to bring in or, which also comes from logic. So we'll just grab this and drop this in here. And that'll be logic. Oh, logic, you silly goose. That's going to be or, not for. That's keywordian. And this will be or. And that'll be logic or. What else do we need? We need is function. And we'll bring that in from here. And notice how we were trying to keep a lot of this stuff in our helper functions. It's okay for this to kind of grow because this is where we're going to integrate with Ramda and Crocs and different things like that, the different libraries that we use. It puts most of our stuff in one place. Later on, we might even export some of these functions so all of our other places tie to this one place. So we're using the same functions about, but we're not going to deal with that too much. So let's put this in order, and we need a pred type. So we'll grab that pred from here. And what else do we need? So we have that where we need mconcat map. So let's bring in mconcat map. And that will go here and delete to big M concat. And this will just be mconcat map. All right, what else do we have? Oops. We'll go here. We need to bring in merge. So let's bring in merge, ME, so that will go here. And we'll bring that in from point free. No, that's in pair. And that is merge. Okay. And we also need to bring in 2 pairs. And I believe 2 pairs is inside of pairs. Johnny 2 pairs. All right, so QRST, and we'll do 2 pairs. And this is going to be in pair, 2 pairs. All right, so let's just make sure our references are good. We might have some errors, things like that. All right, so now we have this function where that we could use. Okay, so let's get rid of some of the other things that we have. All right, and we can move this down. So for instance, how we were doing this was with this same title. We're not going to be comparing by titles, and we want this update record to actually, I don't know, use our query. And we'll just call this query, right? So we're going to change this to query. And then here, we want to do our where here. So that way, we use this as a query language. Now, it's kind of weird because we have it locked down to conjunction. It's always going to be and things along those lines. But it should be all right for now. We can adjust this later. And the other thing that I don't really like about this, that's making it a little difficult, is this should really just be update. And we should be doing that map props inside of there, because what if we want to completely obliterate the object, or what if we want to set something, or I don't know, do an assign or something along those lines. Maybe we want to do some sort of update. So we'll actually have this be a function instead of a string. This needs to be an object, which is our query object. And this is going to be a function that takes an object and returns an object. Okay. And we're still going to take in the object that we want to work on. So basically what we're saying here is when this is true, go ahead and apply this transformation to it. Did you learn all of this category things while applying them to JS, or do you have experience in other pure languages? I have very little experience in Haskell. I use Xmonad, so I know enough to get my desktop going. Most of this was working on, how would you say, in JavaScript. Yuri. Okay, so now that takes a function from object to object, which is then going to take an object and give us back an object. Okay, so now we need to, there's still some things. We don't need map props anymore, and we don't need prop or. So those are all good. But now we need to deal with this query language in here, because remember, it's doing other things. All right, so where we were doing this, let's go to, what is it? Update. All right, update record. So we don't really want to bring in the title. What we want to do now is have the ID. So this will just be the ID. We can bring that in. And here is where we want our map props. And I think I just deleted map props. So now this makes it a little bit easier. And I'm thinking that this map, what are we doing with flip complete? This map should actually go here. And this should actually be the title. Okay. And this is going to be ID now. Okay. And then we're going to remove the map, because that's something that's working on that. Having this flip complete like that, it's bad news bears. It's not very reusable. It's just not good times. Not good times at all. All right, so here let's just break this up. Remember that the first parameter is our query. So basically what we're saying is anytime that we have our ID, or anytime that ID matches, map props. And then we'll just go end a props, and this will be helpers and map props. And map props is like Ramda's evolve, if you're curious. Okay, So now we have flip complete, and let's go like this. Flip complete is going to take a number, and it's going to take an object, and it's going to give back. It's going to take a to-do and give back a to-do. So, and that to-do is going to be either the modified to-do, that's our modification or our update is dictated by this, or it's going to just give us back the same to-do that was there if it didn't need to apply any of the transformations to it. Let's see if there's some of this we could get rid of. I think that's all right. I think that's all right. We could clean that up a bit. But I don't know. I think that's pretty darn good. So now we have a, let's look at our action creators here and how we're actually dispatching this. So if we jump into components, and now you're going to see, like, in case you were wondering why I've set this up to do, where is it? Maybe it's in the container. So there's to-dos. This is going to take the title. So we'll D to this, and we'll just do ID. And then this becomes ID. So you might have been wondering why I just was not putting in a number there, why it was always a, anyway. I just like the interface it provides. Okay, so let's see how broken this is. So if I do gosh, we look at our list of states, and if we notice here, gosh still has 4, completed false, but if I click it, nothing happens. So let's see what's going on with that. We'll jump in our action, and oh goodness gracious. What's going on is when we're actually calling this down in the to-do, we are putting that title in, and that is really silly. So this needs to be ID, and we need to bring in ID from here. Okay, and completed comes before that, so let's do completed, and there we go. Okay. All right, so now everything should be working. Yep. And now we're referenced by ID. Let's see if we cleaned up our bug, laundry. And we've cleaned up our bug. They now iterate, or they now work differently. Each one actually brings in the ID, and if we look at the action, the payload on that is basically just the ID that we want modified. When we add, so if we go to add here, the payload on that is just the title, but we notice that because of our defaults, we get that in as just, that was what, this one? We have like our completed taken care of for us. So I mean, that's just about it. That cleared up our bug. I tried to take some time and explain things a little bit more. I've noticed I've been going through watching these, and I've been going over kind of the mechanics, but not like the high level, like when to use an applicative, when to use a monad, or a chainable, or when to use this aspect of some ADT. I wanted to break down, kind of build, I'm going to be doing more of these, like whenever we're going to build out something. And I wanted to, but started running out of time to kind of show you at each step how this kind of plays out. But this is something that, you know, you could grab and play with. So, awesome. All right. So, I mean, that's it. This is the code. This is what's going on, or this is, I don't know, just a simple way to, or not simple. It's not really simple. There's a lot of concepts here. And so let's kind of see what we've got so far, right? So we have these models that just work on our AppState, and we're able to separate them into different files and different things so they can focus on their context. And that allows us to actually bring in all the transitions. See, we're bringing in the gen ID from this nextId because that's the thing that it's managing. And then we're using that and the applicative form of that to combine the creation of these with the generation of the ID, since both things update state. So the part in that nextID file is working on the parts that increase this like to 5 and every time that we do it. And it's also adding it to the record, whatever the last value was before it actually incremented it, right? So like if we do hello again or something like that for a task, we can then see the tree. Let's look at the state and let's uncheck that. So we notice this went to 6 now, and the ID on the 4th here is 5, right? So now we have a really simple way of doing that. And I mean, I think that's all I got. If anyone has any last minute questions or anything like that, I'd be happy to answer them. I know a lot of people dropped off, which makes me kind of sad. I think I need to reevaluate how I'm doing this. But I'm hoping it was a time constraint or something. But for the remaining few people that are here and signed in, do you happen to have any questions or anything along those lines that I might be able to answer for you right now? Anything you want explained more? Actually, hold on. Let me check something. My son's robotics team is doing their... this is the robot that they built for a first competition. They are in, right now, they are winners, or well, they're second place in their district. So let me see. I might be going to... All right, so they have open shop. So yeah, I'll be doing this same time next week. But the week after that, I may not be able to do it because if they win this next championship this weekend, yeah. So hopefully soon. It could be calculated from that, but I would rather store it in the array. Because we are going to get to a point, like as it sits right now, that's great. But every time that we update that array or update that, we're going to have to fold in on that. And like when we get things like deletion or things like that, oh, he should do fine. They're doing really well. But I will be here next Tuesday, and I'll be coming. I will not be here on the 17th because if they end up going to Houston, I'm a chaperone for the Houston trip. But yeah, it should be a blast. And you're right, you could calculate it from that, but then every single time that we add one of these, we have to reduce that around to pull out the next ID. And it makes it hard to test too, right? Like whenever we build our mocks or do things like that, I mean, it would be really nice to just keep this in the state. The other reason is we can use this to pull all unique IDs from the system. Like we can pull, so we're going to be adding like priorities and tags and things like that. So instead of like creating a new ID for all of those, we now have a source of uniqueness that we can pull from at any time, at any point in our flow. So like when we say add a new priority or add a new tag or label to a certain to-do, then we can just pull from the same ID and make sure that we have unique IDs through every record in our system. Does that make sense, Baris? Or I'm sorry, I probably said your name so wrong. So wrong indeed, and I am sorry about that. I'm a silly, silly Pacific Northwester. So I mean, yeah, like as we're saying, we could calculate that every time, but there's really no need to calculate it. And if we have a bunch of these, we're going to have to calculate it each time we zip on it. And then somehow like either calculate that in an action creator or things like that, which in my opinion might add some complexity to the app. Whereas here we can keep all of that state transition or keep all of that in the state and put the transitions there. Okay. Any other questions? Let's see if I mixed any. Practical way of explaining functional concepts. Yeah, I'm trying. Thank you. Oh my goodness, Sumet. If I'm butchering your names, I am so sorry. It's such a problem for me. But yeah, thank you. I appreciate that. I'm still trying to come up with a way to do this a little more friendly, I guess. And I don't know, this seemed like a good way to do it. And once you get used to these types and you don't have to sit and explain them to everyone, it's actually really quick. But I have to explain like every little bit to this. And then like when we refactor things, if you notice, like that whole time, all I did was just set things up. Yes, usually I'm doing it in selectors, might need. Yeah, so this actually removes. So in case you missed it, this is how our reducers are actually set up, right? So we have these reducers that actually take, so this is our root reducer, and we created this combined reducers to deal with things that return a maybe of a state. So if one of our reducers, if this does not actually ever return a reducer, so notice I'm not bringing in like compose reducers or create action. These are coming from our own like helpers library. And I didn't need to bring in that whole other library since we're using crocks anyway. All I had to do was create two simple functions. One to handle the pattern of, creating these. Where is it? So here's create action that takes the type, the payload, and puts everything together for me. And then over here in combine reducers, all I did was make this simple mconcat or mreduce map that will always get the first one that has the event that I want to apply to, right? So this is really all we need to hook this up. And because every single one of these are going to come from these models that we're creating with these state transitions, all it really is just adding this here, adding the creator, and then putting in whatever the new one's going to be, and then having that state, and we don't need to think about it. And it'll let us like reuse these. So like the add to do, I might be able to use some of the other transitions whenever I'm doing an update to do or something along those lines, as far as like defaulting or something like that. Because we want to make sure that we have defaults if we're doing certain things. So yeah. So what we did is instead of using all of those patterns like selectors and things like that, we removed all of our state transitioning into this model. And what that also gets us is it's now decoupled. All of our state transitions are decoupled from Redux. So if we wanted to use something like HyperApp or another thing that all we really need to do, another state management process, we can just bring these same models in, and however they hook up their actions or their reducers or things like that, all we need to do is we keep the models the same. We just need to implement it at the edge, but it is the same exact logic. If we had this in all of our reducers and used all the Redux stuff and all of that, we now have our state transitions mixed in with Redux itself. But there's nothing stopping us. Oh, I'm so sorry. There's nothing stopping us from taking this whole model folder and moving this to a whole new project, right? So that's the benefit of doing it this way. And we also remove that's why we have to do the selectors, is because we're doing our own compose state. So that's kind of the reason for that. And that's why you see like patterns you might be used to in a normal Redux flow. We've decoupled this from Redux itself and only have it working at those. So, okay, I'm going to give it about another, I don't know, 3 minutes. See if anyone else has any questions or anything like that. Then I'm probably going to call it an evening. I still got some of my day job work I got to finish up. Really stressed out about that right now. Oh, it's ridiculous. But I'll get it done, though. I always get it done. And if you have any other questions, or anything like that, feel free to leave them in comments and things. I'm trying to be very responsive to answering those. And if there's another way you want me to present this, like if you want me to like start talking about adjunctions and like really get crazy with the category theory, I wanted to kind of keep it practical here. But if you want me to get crazy with it, like I can show you like how to get crazy with it here. And maybe I'll do an advanced thing. This is more of an intermediate level. Like, you know how to query. You've read all the Boolean books and the Tom Harding stuff and all of that. This is more like when you're ready to, after that. Like, how do I actually start using this beyond simple examples? Or if you want to present it in another way, whatever works for you, I'm totally open for suggestions. Sweet. Alrighty. And let's see here. Yeah, I think that's just about it. We'll give it another minute here. Alrighty. So I guess next week what we're going to do is we're going to finish up now that we have pretty much everything in this app. The next thing that we're going to do is the last little part of this, which is that silly little visibility filter. And then that's going to end this part of the, this will be the full implementation of the to-dos as they are. So it did add a little extra code, and we did that in the bit to, it cleaned up some of it, made it really nice. It got rid of this internal state that we would have no way of testing or no way of dealing with. nextId. It got rid of this internal state. We got rid of some of this nastiness and changed it into a whole different nastiness, but we have a nastiness that we can take with us, and we're not locked into this. And yeah, so the last part that we need to do is just this visibility, and then we're done with this. Or we're done with what we have implemented here. Then after that, we're going to start getting crazy. We're going to start saving this stuff to local storage, and then maybe have it to where we can have a fallback to call some API somewhere. And then we're going to add things like each one of these should have a description and an associated task list. And if you were to finish everything on the task list, it would finish out and bubble up to here. Like, we'll start getting crazy with it. Each one will have a description. Instead of hitting enter here, if you type in a title and you hit shift enter, it's going to open a modal so you can fill out the whole form. Otherwise, it's just going to give you a empty, basically just a to-do that only has a title in it. And then we're going to add priority labels and other labels so we can adjust the visibility by that and do sorting and stuff with using those attributes. So that's when, see, in this real simple example, this seems like a lot of stuff. Like we have a lot of functions and things like that. But as this grows, the number of functions that we add to this start getting smaller and smaller as patterns start emerging. And then it gets to the point where we just, it's real simply, you put this in, do this, do that, and then everything just works. And if you noticed, going through that, just putting this stuff in, I had no errors. So, like, I was just able to run it because all of the types matched up, everything was great, and we were only working in small parts. So that's, it takes a little bit to put it all together. Oh, goodness gracious, I'm sorry. It takes a little bit to put it all together, but once it's together, it's super nice. It just works very well. So that's all I have for tonight. Thank you so much, everyone, for stopping by. And I will see you same time next week. Talk to you later.